Hello everyone, I'm Tanya Singhal and I'm here to present a report on localized content based image retrieval using evidence confidence, which is a part of my project in for the subject of pattern recognition. Uh, Basically, before I start, I wanted to give some introduction about the topics I've used in my implementation. So the questions which are raised are: what is CBIR? Why image retrieval classification based on regions is hard? How are images represented? And what are the current existing methods used to classify images? The previous methods present for retrieving images are MILES and DDSVM. MILES stand for Multiple Instances Embedded Instance Selection, and DDSVM stands for Diverse Density Support Vector Machine. The proposed method, which I have shown in my report, which is better than the other two, is called ECSVM, which stands for Evidence Confidence Support Vector Machine. In the end, I'll show the performance evaluations and conclusion, which is basically to show how the new proposed method ECSVM is better than the previous two I mentioned, which were DDSVM and MILES, using the two data sets mentioned in the report, which are called SIBAL and Coral dataset. So, what is CBIR? CBIR means content, it stands for content based image retrieval. In existing systems, images can be retrieved on the basis of features like color, texture, shape, etc. The user needs to specify region in the query region to classify images from a pool of images. In the previous methods like QBISC, user had to specify the region to classify images, but in CBIR, search analyzes the content of the image rather than the metadata. CBIR major classes are two, which are global method and the localized CBIR method. The global method exploits uh, features that represents the global view of an image, such as color, figures to compute similarity, and is easy to be identified. Whereas the localized CBIR method, in it, the user is only concerned about a portion of image and the rest is considered as irrelevant or useless. This makes the classification of image more natural and in line with the requirements of the user and suitable for human viewpoint. MIL, which stands for Multiple Instance Learning. In it, each bag corresponds to a single image and may contain multiple instances. Every instance maps to a description of some sub-region of the image. And in there's one more, single instance learning, SIL. It is used to refer the traditional supervised learning paradigm in which single examples has a class label. Moving away from the traditional, I will demonstrate how a system can automatically learn the interest of the user by using the relevance feedback method or by inputting a query image as a set labeled as positive or negative as per the images that contain the target regions of interest. Images are basically viewed as bags, each of which may contain a number of instances matching to regions obtained from image segmentation. MIL assumes that a bag is labeled positive if at least it has one instance as positive, and similarly for the negative classification. TDSVM labels a bag based on some number of instances satisfying the number of properties. There's one more, MILES. MILES also converts MIL into SIL. It represents bags with highest dimensionality, that is to many irrelevant features. Classifiers that can use feature depiction in MILES are limited as compared to those which can perform both feature selection and classification concurrently. This is the reason to design an efficient feature representation scheme to represent bags in multiple instance learning, which is MIL. There are several CBIR techniques. Some of them are query techniques, semantic retrieval, and iterative or machine learning. Query techniques, in it, the query that involves by providing a query to the CBIR system that will base its search upon. Underlying search algorithms may differ based on the type of application. Semantic retrieval, It's basically they basically make use of local low level features like texture, shape, color used in combination with some interface which allows easier input of the criteria or with trained database. Iterative or machine learning, it basically makes the CBI system to depend and understand the user intent to a greater extent. Then the proposed algorithm which I mentioned was EC-SVM, Evidence Confidence Support Vector Machine. Uh, it is an evidence region identification method to identify that support the labels of the images. Computationality efficient and robust to labeling noise is proposed to describe the bags based on identified evidence regions. What the difference between EC and DD? The main difference between EC and DD can be easily seen from the EC value, which is the evidence confidence value, which is defined only for the observed instances and can be directly computed from the training data, while DD tries to maximize an objective function, that is to search for the target point, which is a continuous space with infinitely many members. This diagram shows the main difference between the DD and the EC. In the DD direct diverse density, the training data is passed for direct computation and gives the evidence confidence values, while in EC flow, the training data is first optimized and then it's further computed to give the values of EC. The advantages of EC-SVM, there are many. Some of them are that value of each observed instance is directly computed from both the training set. Therefore, the method has no parameters to tune, making it several orders of magnitude faster than DD-based methods. In the proposed method, the evidence instance identification method constrains the search scope for identifying evidence instances to be within a bag. Finally, what I got obtained by performing the experiment was that the experiment of EC-SVM is based on two publicly available image data sets, the SIVAL SIVAL spatially independent variable area and lighting image set, and the coral image dataset. This dataset that I have used in this project comprises of 1500 to 1600 images in 25 different categories and contains 60 images for each category. I selected 8 positive and 8 negative images from the full set of these images. The rest were used to create the training set, the test set. In my experiment, I am showing the result on the basis of 30 rounds of independent sets. In order to get the best performance for the following experiment, I am setting parameters C and Gaussian kernel as 1 and 2 to the power minus 4 respectively for SVM. The average area under the ROC curve values with 95% confidence interval for the 25 categories. These results, when compared with previously existing methods, gave that EC results in the highest performance. Similarly, on Coral dataset, the results of the average area under ROC curve was 95% for all the 20 categories over the 50 rounds of test, and once again EC-SVM was seen to give the better performance. The experiments has been formed by comparing the EC-SVM with DD-SVM and miles with varying noise labels classified on different categories like historical, building and horses. This figure shows how EC-SVM proves to be better than miles in both the datasets, which was SIVAL and Coral. The difference between SIVAL and Coral datasets is the SIVAL dataset differs from the Coral dataset in many aspects. Like in Coral, the target object occupies a large portion of the whole image, while in SIVAL, the main part of an image is the background. Furthermore, the background of some categories in Coral is always specific to that category of images. The computational cost refers to the time taken to train the classifiers on several categories. For SIVAL, this time refers to the training of 25 classifiers for 25 categories, taking 4 positive and 4 negative images, whereas in Coral dataset, this time refers to the training of 20 classifiers for 20 categories. Finally, the conclusion I got from by performing my experiment was that basically I wanted to explain how high computation cost and high noise of diverse density support vector machine, which is DDSVM, and high dimensionality of miles is what I achieved by performing the experiment. The proposed method by the author of Evidence Confidence Support Vector Machine is a practical approach to effectively explain the bags in multiple instance learning, which is MIL. Thank you.